All right, let's get started, everybody. I'll let people in as we're going. So thank you, everyone, for joining us for our September meetup on Idiomatic Pandas. So last month we were in person, and the turnout was okay, right? There were some folks that wanted to do in person, but with everything going on, we're going to try some more virtual, which is awesome because what that allowed me to do was find an amazing speaker, Matt, who's an O'Reilly author and really an expert. If you just search his name, you're going to find a wealth of things that he's worked on, including something he called Metasnake. He has a lot of books, a lot of courses, and we were just trying to, chat a little bit before the talk. And he's always making new material. So I think definitely if you want to learn about Python, you want to learn about how to do how to do pandas correctly, this will be a great talk for everyone. So to get started, I usually just like to thank our speakers, do some brief announcements, and then I'm going to hand it over to Matt. So let's go through this real quick. So Variant Technologies is a defense contracting company. I've been supporting the meetup for several years now. They do some interesting work across the board. If you're ever interested in learning more, I'm always appreciative of the companies that give back to the community. If you're ever curious of working with them, please reach out to either them or myself. ClearEdge is another company that again does a lot in the Maryland area with data science. Has really been supportive of the group. We're trying to do a conference together. They used to do things with the Cumulo Summit, if you're familiar with that, or folks that are familiar with that. So again, please reach out to them, give them consideration. Areas Ventures is my company. I usually just highlight that very quick. If you're ever just curious what we're doing, I'm trying to do cool things. Just reach out and I'll share, what we're doing and see if there's a fit. Always looking for good people, of course. And a small company decided to start working with us, Microsoft. So if you're interested in working with them, they're doing, of course, an amazing amount of things and trying to see if we can do something where we can get some Azure credits. But there's a POC that I've been working with, and if you have any questions about what Microsoft can offer or some of their things, please reach out. I'll make the introduction. They're always looking for good people, also, and our group always has some interesting and really smart folks doing data science and analytics. So the next couple months are kind of already booked, and next month I'm really excited. We're gonna have a speaker from the company called Enveil, which they do. And actually, I'm gonna butcher this. It's like homeomorphic encryption, but basically the gist is that you keep the data encrypted and you can actually work with the data. If you look up Enveil, you'll see it's a really interesting company. They constantly are being awarded prizes through RSA and everything. So if you're interested in that, please tune in. And then in November, we'll have a talk on blockchain. That's the idea right now. We have a newsletter we send out. Always looking for help, always looking for speakers. Very easy to get in touch with me, either through the meetup, LinkedIn, or whatnot. So feel free to always ping me. We are trying to do a conference. It was supposed to be in September. I ended up postponing it. We're going to evaluate in a month how we're going to do it. I would like to do it in person. I really would love to have help from speakers. If you have anything, as anyone's interested in being involved, please reach out. So, I put the wrong thing. So let's ignore the screen because it's a copy and paste error. So I'm just actually going to stop sharing because but basically Matt is an expert in Python and data science. He has a CS degree in from Stanford University, and he's the best-selling author of Python and data subjects. His books, Illustrated Guide to Learning Python, Intermediate Python, Learning the Pandas Library, and Effective PyCharm, have all been best-selling books on Amazon. He's also worked on machine learning, pocket references, Pandas Cookbook, and he has taught a wealth of companies from anything from Netflix to NASA to Verizon. He's active on Twitter. I can share that in a little bit. And he basically is one of the experts in the field. So the way that we're going to handle questions, Matt said he was comfortable with questions during. If you have a question, please post it in the chat. I'll be monitoring that. And for those that are watching through YouTube, I'm going to be monitoring the chat there also. So just send that, and I'll ask the question. So with that, Matt, I'm going to mute myself, and you can share the screen, and it's all you.
Okay. Thanks, Jason. Hello, everyone. Feel free to turn on your webcams if you're willing to. Always nice to see a face that's moving rather than, I guess, a non-face. So I appreciate that. But let's get started here. sharing my screen. Hopefully you can see it. Actually, I'm going to stop that really quick. Let me try one more time here. Okay. Okay, hopefully you can see my screen now. And it's really nice to be here. So thanks, Jason, for letting me come and chat with you all. So as Jason said, I run a company called Metasnake. Metasnake does corporate training consulting, mostly in the Python and data science sphere, and mostly to bigger companies. However, always happy to chat with smaller teams and whatnot. Already booking out training for next year. So if your team needs training and wants to get up to speed, let me know. Happy to reach out. I'm also, like Jason said, on Twitter. So that's __M Harrison _ or Dunder M Harrison if you're familiar with Python. And like Jason said, I've written a couple books here, and excited to share some knowledge with you. Also, I do run. Generally, most of my training is for teams. I do run individual type stuff as well. So I'm going to be running a workshop called the Idiomatic Pandas workshop. Idea here is to basically take these ideas. You come into the workshop with your code and basically get a chance to work on that, ask questions, apply what you're learning there. So if you're interested in that, that will be coming up. Again, you can reach out to me on Twitter, alternatively LinkedIn if you want to as well. Okay, so here's what we're going to be talking about today. And just full disclosure, this is not an introduction to pandas. So if you're looking for an introduction to pandas, I can refer you to a lot of good resources for that, but this is not that. So this talk is a talk from my experience of basically using pandas for a long time, writing books on pandas, teaching pandas to a lot of people, and seeing a lot of people's code and finding out some best practices and things that people aren't using, and helping teams write better code. So one of my goals when I'm teaching, I like to tell students, is you want your code to be readable. Code is typically written once or twice, but it's read a lot more. I mean, sometimes, some of this analytic stuff is barely written and read once, and it's just throwaway. But oftentimes, we want to take it into production or do something a little bit more useful with it. And so my goal here is, not just throwaway code. I mean, if you're doing throwaway stuff, you might as well use Excel. It's going to be a lot easier generally than something like Pandas. But if you want something that you can eventually, take and put it into production or something like that, then a lot of what I'm talking about will apply to you. So again, not an introduction to Pandas, but some best practices and some things that I see that a lot of people either don't know about or are skipping. So as Jason said, if you do have questions or concerns or comments, if you've got your video, feel free to raise it or raise your virtual hand. Happy to take those either via audio or via chat as well. What we're going to do is we're going to look at a data set, and I'll talk about a few things. I'm going to talk about, I'm going to load the data, then we'll talk about, inferring types for your data and using the correct types. We'll talk about this idea of chaining. We'll look at mutating data, when you should do that. We'll talk about function application, when you should do that, and we'll wrap up with aggregation and just some tips along the way here. So with that, let's get started. I'm just going to be sharing this notebook here, so there aren't really slides, just all going to be notebook driven here. I'm going to run this code here. So I am using Pandas 1.3.2, which is sort of the latest and greatest. Having said that, there's nothing in this talk that's particular to Pandas versions that are, anything that's 3 years old or 4 years old with pandas, this talk will probably work with that code. So it's not like there's new cool stuff in pandas that you need to use. This is like, if you're using pandas, most of this functionality has been available for quite a while, and a lot of people are not aware of it. Apologize for drinking on the screen, but I've been teaching for like 7 hours today, so I just want to keep my voice moving here. I'm just going to do some settings here for Jupyter to change the number of rows, and I'm going to load this data set. So this data set that I'm loading here, okay, so there's a question, what font am I using? So I believe this is Iosevka, Daniel. So okay, so the data set that I am using is, it's on my GitHub, but it's from fueleconomy.gov, and I don't know, I guess a lot of you are probably work with the government or whatnot, so maybe you're more familiar with this than I am. But basically, my understanding is the US government has this, every car that's sold, not every individual car, but every make and model type that's sold in the US needs to submit data to the US government about fuel emissions, that sort of thing. And so this is the data set that has that information in it. I'm just going to load this up. It's in a zip file. I put it on my GitHub, but you can get it from fueleconomy.gov as well. And it looks like this. This is a pandas data frame. After you load the code here, you've got something that looks like this. It's got 41,000 rows and 83 columns. So you can't really see all the columns here, but it's got like fuel economy, make, model, year, and stuff about electric cars and whatnot. So a nice little data set. Here's the columns that are in there. So how many barrels of gas a car uses, what the charge is for electric cars, city mileage, highway mileage, combined mileage, blah, 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 blah. So 83 columns here. I'm not going to use all of these columns, so I'll split it out just to make it a little bit more manageable for this. And also, full disclosure, like I said, I'm not a car expert or subject matter expert on these things. So if I lead you astray or something I say sounds weird or wrong, feel free to give me advice or tell me what's going on. But hopefully, the data set that we're looking at isn't particularly interesting or important here. It's more the concepts, and this data set is just a pedagogical example that we're going to use. So I'm going to pull off some columns. I'm going to pull off the city mileage. This is how many miles per gallon that vehicle will get in the city. We've got what's called COMB08. That's a combination of city and highway mileage, and I'm not quite sure how that's calculated. We've got cylinders or highway mileage as well. We've got the number of cylinders in a car, the engine displacement, the drive of a car, this engine description, the fuel cost, which is like how much you'll spend, I believe, per year buying fuel, make, model, transmission type, the range, that's for electric vehicles, created on, which is a date when this entry was created, and the year. Okay, so I'm just going to I'll run this here and make this variable here, and let's pull those out. And when you do the D types on this resulting data frame here, you'll see that there are various types in here. There's int64 types, float64 objects. And if you're not familiar with this, just by looking at this can tell you quite a bit about your data. First of all, lowercase int64 type is not a Python type. So even though pandas is a Python library, int64 is not a Python type, neither is float64. And so this is maybe the dirty secret, and perhaps the reason why Python is as popular as it is today is because pandas is built on top of this library called Numpy, and Numpy is a library for manipulating matrices or arrays of data. And Python is a slow library. If I teach beginning Python classes, and sort of the first thing I go over in that is that everything is an object. And so it's not like there are native data types, sort of like C or even Java, where a float is a native float type in Python. Rather, it's an object. And so there's overhead to that. It makes coding easy, but it also makes Python slow and a little bit more memory hungry. So why would people use Python for like doing machine learning, these tasks that require a lot of memory and fast computation? It's because the internals of these are not leveraging Python under the cover. They're leveraging, code written in C or Fortran that's very fast and optimized and can take advantage of modern CPU architectures and do like SIMD instructions, where you have an operation on a block of data and you can vectorize and broadcast that operation without pulling it back into Python. And so basically you get a lot of speed and performance increases by using a library like Pandas versus doing this in raw, pure Python itself. A couple more things. So Int64, this is like a C type. It means an 8-byte wide integer. When Pandas like reads the city column, what it's doing is it's actually allocating like 40,000 8-byte integers in a block of data. And then similar for floats, it's doing 40,000 blocks of 8-byte floats. Now, object there is a little bit different. These Pandas types aren't really optimized for string information. And so when you have an object column, typically that's string data. And what it's doing is it's pointing back to a Python string for each of those string objects. So if you're doing numeric processing, you get quite a bit of speed boost by doing that. By doing string processing in and of itself, not so much unless you leverage something like categorical data types, which we'll show a little bit of as well. Now, a couple other things to note just by looking at this type, and maybe this is minutia, but like, for example, Int64, the Int64 type in Pandas does not support missing data. So by looking at this data right here, I know that city, combined, highway, and fuel cost, and range, and year, none of those columns are missing data. And if you've done anything with data, you'll know that missing data is something that's pretty important to know about, especially if you're doing like machine learning, because many machine learning models, if you have missing data, will just fail and they won't work if you have missing data. So generally, we do need to do something about that missing data. Now, float, on the other hand, float64 in Pandas does support missing values. And so when I see a float column, that tells me typically one of three things. One is that it's floating point number and there aren't missing values. Two, it's floating point and there are missing values. Or three, it's integer-like, but it had missing values. So Pandas, since lowercase int64 does not support missing values, it converted it to that. That's just something to be aware of. You can infer that just by looking at this data. Now, again, object, that also tells me that this is generally a string, but it could also be a mixed type. Oftentimes when you read a CSV file, comma separated value file, there is great thing about those is that they're human readable. They're sort of ubiquitous. Bad thing about them is they don't carry type information. And until recently, there wasn't really a standard. Now there is a standard, but I mean, it's sort of after the point that ship has already sailed at this point. And so there's lots of different ways to make these CSV files. And so object could mean that it's a string column. And string columns could be like categorical strings, could be nominal strings that have, or categories that have order, that are ordinal. It could be free-form text. It could be dates that are represented strings, and it could be numeric data that for some reason had some character in it that Pandas didn't understand, so it left it as a string. So typically we want to explore these object columns and make sure they really are string-like, or we might need to take further action on them. Okay, any questions about other than font questions here? Okay, I'll keep cruising along then. So what I'll do here is I'll just run this memory usage, and I do deep is equal to true. The reason you want to say deep there is because those object columns like make and model, those are pointing at strings. And if you don't say deep, you just get how much memory, like the underlying block of data is, but you don't get the data that is pointing to Python objects. So by pointing to Python objects, you get, or by saying deep, you get also the Python information as well. So if you sum those up, you get like 19 megs. So this data set is like 19 megs in memory. And Pandas is an in-memory tool. You need to sort of fit it into memory. Okay, so let's just go through some process for cleaning these up a little bit. I'm going to select the integers here, and I'm going to do this describe method right here. So if you're not familiar with it, one time I was teaching this to some clients, and I showed them describe, and someone like smacked their head after I did that. And I said, what's wrong? What did I say? And they said, well, we just spent the last couple of weeks implementing describe for a BI system. If we had known about this, then life would have been a lot easier. But this just sort of shows you the power of Pandas. With a simple single piece of code, you can get a lot done. So this is summary statistics for all the integer columns in this case. So I like to go through this and just look at this information here. So one thing to be aware of here is that count in Pandas land has a specific meaning. And it's not the count of the rows, it's the count of the non-missing data there. So by looking at this, and I already know this because they're integers, that none of these rows should be missing. But if I instead of doing int type, I just did describe on everything. I might see some of these like cylinders that are not 41,144 because they are missing values in there. So I like to go through this and just sort of, you got the mean, the standard deviation, the minimum, the maximum, and the quartiles there. And what you can do is you can sort of like look at things like, okay, we've got highway that only goes up to 124, and I'm using an 8-byte integer for that. Really, do I need to use an 8-byte integer to hold up to 124? Probably not, right? The other ones might not get away with a single byte or a smaller integer, or it certainly can get away with smaller, not necessarily needing an 8-byte integer for that. Now, another thing to note about this is the way it's written up here. I'm chaining some operations here and just putting them on a single line. This is a single line of code, but remember back to what I talk about when I'm teaching my students, I say you want your code to be readable. And is this code readable? It's okay, but it can be more readable. And we can make it more readable just by doing some simple things. We put parentheses around it. Parentheses mean a couple things in Python, but one of the things that they mean is that it's a parenthetical. And so, if you're familiar with math, if you want to do addition before multiplication, you put parentheses around it. And Python supports that operation as well. So Python will let you put parentheses around whatever you want. And if you put parentheses around an operation like a pandas operation, it lets you basically escape Python white space rules. And so what I like to do is I like to take each of these operations and put them on their own line. It just lets me read it like a recipe here. So here's my original data frame. And then what I'm going to do is I'm going to pull out certain columns. So this pulls out certain columns. And then what I'm going to do is I'm going to, from that, I'm going to sub-select integer columns. And so there's the subset selection of that. And then from that, I'm going to do a describe here. And so here is my describe on that. So if you write your code like this, it reads like a recipe. Do this step, then do this step, and then do this step. One question from Ed here. If you're only using a subset of columns, it would be faster in later steps if you set autos is equal to autos.com. Yeah, I mean, if you're only using a certain set, and then you would probably want to, make some data frame that's the limited set that you want to. On that, I will say, Ed, that I generally recommend working with raw data rather than manipulated data. But if you have intermediate data frames or whatnot to speed up processing. That makes sense. But inevitably, my experience, again, sample size one, but I've taught at a bunch of big companies and consulted and trained and worked for various companies. Inevitably, your boss, after you do some analysis, comes to you and says, will you explain this data, right? And if you're working with some weird intermediate data set that you can't go back to the raw data from, makes it a little bit hard. When you're using something like this chain style here, you can basically trace your data through the whole process, and it makes it a lot easier. Xiaoping says, does this make your code really long? Maybe. I would say this. I mean, if you want to put it on one line, you can. But my take is you want to make it easier to read, and putting it on separate lines is going to make it a lot easier to read. So I'd much prefer to make it easier to read rather than to worry about how long it is. Now, maybe your question is also like, you're using this chaining style versus some other style. If you use some other style, maybe your code won't be as long. Well, you're going to do the same steps regardless, basically, if you're using chaining or whatnot. My experience is that chaining, and I've got an example down here below, it's actually shorter than non-chained code. So hopefully that answers your question. Okay, so let's just look at some of these here. So with Numpy, the Numpy library, I can inspect information about the int8. Again, that's not a Python type, but it's basically a C type that Numpy is wrapping for us, and it tells you that the maximum value of that is 127. So if we use that int8, we can replace highway with that type of column. Turns out that if we use unsigned integers, and we probably could use unsigned integers because all of these are positive numbers, we could probably replace most of these with uint8. But in this case, I'm just going to use an int16 instead. Int16 goes up to 32,000 from negative 32,000. And so all of these are less than 32,000. So we should be good there. So what I'm going to do now is I'm just going to go through this process here, but I'm going to stick in this operation right here as type. So this is basically a mapping. It's going to say, take this column and convert the types. So we're going to change highway to int8, city to int8, combined, or city to int16 combined to int16. And then we'll look at these that are integers and int8s. These don't include the int16s in here, but these ones that we do have, like highway, looks like we haven't lost any granularity here. So that looks okay there. What I'm going to do is I'm just going to shove everything else in here. So put everything else as int16s here. And in this case, I'm going to say select D types, and I'm going to say the string integer. This is a little bit weird. Like up here, if you just say int, it doesn't select those smaller types for whatever reason. And my goal here isn't to say that like pandas is the greatest thing ever. My goal here is to help you write pandas code. So there are a lot of things in pandas that might be confusing or suboptimal. But at this point, it is what it is. And so if you do look at the result of that, it looks like, we're not losing any granularity by doing that. However, if we look at our memory usage now, we've shaved off like a megabyte, a little bit more, megabyte and a half of memory. So, about 7% or so we shaved off by doing that. So we can sort of go through a similar process here and look at floats as well. So here, let's just pull off the float columns. There's two. There's cylinders and the displacement. Now, by looking at this, if you look at cylinders here, they look like they're actually integer-like, right? I mean, these are whole numbers. And if you think about cylinders, it's the number of cylinders in your car. When you're counting something, generally counting something is a whole number. So this is an indication to me that there's probably missing values in that. Displacement, on the other hand, looks like a floating point number. Okay, so what I like to do is I like to do this describe here, and we'll just do describe on cylinders. And look at that. You can see that the count indeed is not the 41,000. So there are missing values in there. Another thing that you can do is you can do a value counts here. And I'm going to say drop NA is false. That includes the missing values in there. And if you do that, you can see that there are 206 values where there are not entries for cylinders, but everything else is a whole number, right? So you may not know that there's like 2-cylinder, 3-cylinder, 5-cylinder cars. Again, I'm not car expert, but a 5-cylinder car seems a little bit weird to me, but it is what it is. So let's do some exploration here and look where these values are missing. So again, I'm going to just chain this operation up. I'm going to say, here's my original data frame. Let's plot these columns here. And then let's do a query here. So a lot of people aren't familiar with the query method, but basically allows you to do sort of like a SQL string with a query. So I'm going to say, where is cylinders is NA? So is NA is actually a method here, but we can pass that. We can include that in our string here. And these are the rows where this data is missing. So you can scroll down here, you can see that there's 206 rows where it's missing. We can sort of scroll through over here and look at the makes and the models. And if you sort of look at most of these and squint, most of them look like they're electric cars, which sort of makes sense. There's a few that aren't, and I'm going to just sort of ignore those for now, say that they're bad data entry, but a lot of these look like electric cars. So electric cars, from my understanding, do not have cylinders in them, right? And so a lot of missing data can be a pain to deal with. I mean, I got a book on my bookshelf here about ways to deal with missing data, and it's like this thick, very technical, academic, dry book, right? And so you could have a full semester-long course on dealing with missing data. I'm going to just say, well, in this case, I want to overwrite cylinders. So I'm going to use this assign method. And I'm going to say, I want to take cylinders and make a new column called cylinders. And I'm just going to fill in the missing values with 0 and then convert that to an int 8, right? And then displacement, similarly, if there is no displacement in the engine, I'm just going to say it's 0. And so if we do that and look at our result here, we can see that we don't have any missing values here with cylinders and displacement. Now, is that the correct thing to do? I mean, again, typically my recommendation for dealing with missing data is to talk to a subject matter expert. It might be the best to drop it. You may be filled in with some value, maybe filled in with a mean, maybe 0 works, maybe make a machine learning model. So there are various things that you can do or should do. So this is looking okay now. Here's all of our data. Again, if you compare these from the cleaned up, we aren't missing those values anymore, so that might be good. We can also similarly inspect these float sizes, right? And what sort of granularity or resolution do we need with floats? And so I'm just going to say, well, for example, for like displacement, I'm going to convert that to a float 16 here. And does that look like it's doing okay? And you can sort of inspect that and say, yeah, that's sufficient, or maybe it's not sufficient. But if I take the cylinders, convert that to an integer 8, and then convert displacement to a float 16, then we're down to like 17 megs. So we've saved like 2 megs now of our data. Let's look at object types here. Let's see if there are any questions. William says we can do add addition and subtraction in pandas columns like x plus y, but we cannot do logic problems. Not quite sure what you mean by logic. You mean like bitwise logic, or do you mean like if this then that? Because pandas supports both Boolean logic and binary operations. So William, not quite sure. Maybe if you have an example, I can address it, but pandas does support logic. Yeah, so yeah, William said it like if x is greater than 10, y is equal to something. Yeah, so pandas supports that. I have an example in here that we can look at. Okay, so let's look at the object columns. Here's the object columns in here. So we've got like drive. This looks categorical. So I just like to go through these and sort of understand what's going on here. This engine description looks maybe like weird. It's got parentheses. I don't know why it has parentheses. It's got like commas in it. So maybe it's like sequences. It's represented in a single column. It looks, and this is weird. It's got like double parentheses here. So this is like kind of messed up data. This second column here. Needs some further exploration. The make here looks categorical. The model is probably high cardinality categorical. probably some repetitions, but not a lot necessarily, especially when you start taking into account like the Camry EX versus the Camry SL and the Camry XLE and whatever. But, there's probably some duplicates in there. Transmission, looking at transmission actually looks like it's a composition of 2 column types, whether something is manual and automatic and the number of speeds. So we'll see that I actually split those apart into 2 columns. And this created on actually doesn't look like a string column. It looks like a date column. So we'll deal with each of these different columns here. Let's start off with drive. When I take an object column, I like to do value counts on it. So I'm going to do value counts. I'm going to say drop NA is equal to false. This is going to give us the frequency of the entries there. You can see that there's 1,100 missing values in drive. So what does that even mean, right? Missing values in drive. Not quite sure, right? So you can sort of, again, we can go in here and we can query this. Let's query where those values are missing. And there's 1,100 of them. And let's just sort of look at the makes and models and try and figure it out. And it looks like a lot of these, EV, Ford Think, a lot of these are electric cars, but some of them are not, like Chevy Corvette, Nissan 300, Mercury Grand Marquis wagon. So interesting that these do not have this drive here. Are these like 1-wheel drive, half-wheel drive? Not quite sure what's going on here. Lotus Esprit V8. A lot of them are electric, but some of them are not. Again, so this might require further sort of slicing and dicing of the data. But what I'm going to do is I'm just going to say, if it is missing, we'll just fill it in with other, right? This is another type of drive. I could do further logic to say if it's missing and it's electric or something, fill it in with electric other versus combustion other. But for now, I'm just doing this. And note that I'm also saying convert this to a category type. And and then make here, I'm going to convert make to a category as well. Let's look at the memory usage from that. We're now down to 12 megs. So just by changing those 2 types, we basically saved about 1/3 of our memory. And again, that's due to the fact that Pandas was pointing to strings under the covers, Python strings, but when we convert it to categoricals, especially if they're low cardinality with a bunch of repetitions, it can save a lot of memory that way. And so this drive had a bunch of repetitions, as does make. Okay, let's deal with transmission a little bit. Again, I'm just going to drop that into value counts here. And here is our transmission report. You can see that this, again, like I said, looks like it's 2 pieces of data. And whether it's automatic and manual, and whether it's 4-speed or how many number of speeds. There's also some missing values in there. We could go through that process of filling that in. But basically what I'm going to do is I'm not going to do as intense of analysis there, but I'm going to sort of split this apart. I'm going to say, I'm going to make a new column called automatic. And it's just whether that column contains auto in there. And then I'm going to do another column called speeds. And that's just going to use a regular expression to match any digit inside of that tranny column. And if it doesn't match anything, fill in the missing values with 20. So again, this is my not being a subject matter expert, but saying like, if we don't have a number of speeds in there, it's electric. Electrics are sort of like variable speeds or whatnot. So I'm just going to say 20 to sort of give it a number in there. And then we're converting these all to int 8s. Okay. So let's look, and then I'm going to drop that transmission column because I don't really want it anymore. I've extracted the data that I want out of it. Now we're down to like 10 megs. So we're basically like half as much memory as we started out with just by going through this. And, when I'm teaching this or I'm doing a consulting gig for a client or whatnot, I do recommend basically doing this manual process of looking through all the columns that are interesting. There are tools that will sort of like say, here, just run this and like, it will sort of give you summary statistics and reporting on all of your columns. I think that's sort of a bit overwhelming to me. It is useful to go through each column individually and start trying to understand them. And, if you read this, it looks like a recipe, right? Here's my original data. We're going to pull off these columns. I'm going to update the cylinders column to this, the displacement column to this. I'm going to make a drive column. I'm going to make an automatic column. I'm going to make a speeds column. I'm converting types here. I'm dropping the transmission column. And then I'm chaining these operations on down here. But eventually I'll remove those and I'll just have my cleaned up data. Okay, any questions about this? And Nissa says, can you record this to YouTube live? I'm assuming is being recorded. Jason, can I address that, I guess? But...
Yeah, I responded to her. I usually clean it up at the end and it'll be on YouTube with links and stuff to the things.
Oh, okay, awesome. Yeah, anyone else have questions? William had a question. We'll get to William's questions. So, okay. Hopefully I'm not boring everyone to death. But hopefully this is useful. I'm just looking at a sea of like names here, so not really able to see much interaction. Okay, Daniel says great information. Awesome, Daniel. Thanks for the feedback. Okay, let's talk about dealing with dates now. There is this created on column, so I'm just going to throw this into my assign here. Let's use pandas to convert that to a date time, and we'll run this. And I get, if you look at that, I'm down to 7 megs now. I do have this pink warning of death here. If you use pandas very often, you might see these annoying warnings here. Basically, if you look at this, pandas doesn't like this EST column. So all of you who are in the EST time zone over there, I'm not in that, but all of you, I imagine a lot of you are. Pandas doesn't like you for whatever reason. And if you mess around with numbers, you find out that numbers are kind of a pain. Well, dates are kind of a pain, and time zones are kind of a pain, and handling them in a smart way is kind of a pain as well. But turns out that I can do this in pandas. In fact, I think I mentioned I'm writing a book here, a new book on pandas right now. And I spent like multiple days just like researching time series manipulation with and dealing with time zones for pandas. And this is like some of my notes that I went through, but it was kind of a pain. But I think I've got most of it figured out. But basically, what I need to do here is I need to replace these EDTs and ESTs with offsets here. And then I'm going to convert that to a UTC time. And then once it's converted to a UTC time with offsets, I can then convert it to the actual IANA name of the time zone, which is America, New York, instead of EST. It turns out that EST and EDT really don't mean anything other than that's an offset, versus America, New York has a specific meaning. So if I run this, that seems to work. Notice that I don't get this pink splotch of like, you don't know how to handle times here. That goes away. So I'm just immediately jumping on to my next thing. This is my time zone manipulation, which again is sort of a pain. Finding that information is a pain. There isn't a bunch of it on the internet. Hence one of the reasons for my new book, because I tend to read everything pandas related, and there's just not a lot of good information on time zones in general, let alone on pandas. So anyway, I'm going to jump down to engine description. So I'll just do our value counts here. When I get a categorical column, I like value counts. And you can see like 16,000 of them are missing. Some of them have parentheses, some of them don't. Some of them are combinations. Some of them have like 7 spaces in between them. Some of them have commas. Some of them have spaces in between the parentheses. So, if you've dealt with data like this, you know that data is messy, and this looks like just messy data. So you could probably spend quite a bit of time sort of slicing and dicing this. You can see that there's 558 unique types. A lot of these are sort of outliers where there's one of them. Looks like, this is a form where they had free form text. So a hint, if you're doing a survey, don't have free form text in it. If you need to slice and dice your data, you're going to get just horrible data like this. Anyway, again, talk to a subject matter expert. But what I'm going to do here is I'm just going to add this FFS column. It looks like a lot of them have FFS in them for whatever reason. It turns out that FFS is a feedback fuel system. So it looks like that might be important. Again, I'm not a subject matter expert here, but apparently the US government thought that was interesting, such that they put it in parentheses in a lot of these entries here. So I'm going to just make an indicator column with that in there. And that's a Boolean column. And then I'm going to drop the engine description after I do that. And so let's look at our memory usage now. Our memory usage is now down to 6.7 megs from originally almost 20, right? So less than a third of the original size. We've gone through some cleaning up of our data along the way. And at this point, what I'm going to do is I'm going to take this glorious chain here, and I'm going to make a function from it called tweak autos. And here is my tweak function. It's going to take the raw data and it's just going to put it through this chain here to clean it up, right? Let's just try that out. And it looks like that works. Okay, so my take on this is this is the process that I would use if I'm consulting or working for a client or working on my own project. I would go through this process of cleaning up the data. After I've done this, I will have built up this chain. I will throw this in a function and I will put it in my notebook in the cell immediately after I load the data. The next time I come to my notebook, which might be tomorrow or later in the day, might be in 3 months, it might be in a year, my colleagues might see it. They don't have to like go through all of these cells and sort of go through and figure out what I'm doing. It's all right there. It reads in an orderly manner. And if they want to take this function out and put it in a script or something like that, it's easy and it works. So highly recommend you adopt something like this, especially if you're using Jupyter. It's going to make your life a lot easier. Any questions about this so far? Yeah, Nick asked, do I keep all the subsequent code cells? Depends. I mean, if I want that, but generally at this point, I don't care about all that other stuff unless there's like useful information. So, you know, that is what we have Git these days, so we can keep track of source control if I need that. But, you know, if I was delivering something to a client, unless they were interested in sort of like why I did what I did, I would just give them, you know, this tweak here and be done with it. Ed says you should still check the data with each new load as things change. Yeah, that's a good point. And so, yeah, you might want to put some tests in there or whatnot to do testing with your data in case things change. And I do, I talk about testing data in both the Pandas cookbook and in my new Pandas book as well about testing that. Okay, so this chain, so that is the first section, just types. The second section here is chaining. So this is what we just saw here, where I'm putting these operations one after another. This is also called flow programming. And rather than making these intermediate variables that I see 90+% of Pandas people using, we should just leverage the fact that most Pandas operations return a new object. And we should work on that. What this forces you to do is it forces you to think in a logical manner. And if you do that and write your code in this way, it's going to read a lot clearer because it's a step-by-step process. And it actually, like I said, reads like a recipe. Some people might object or say like, oh, there's some things I can't do with chains or whatnot. Turns out you can do everything with chains because there is a method in Pandas called pipe. And pipe is a method on a data frame that takes an arbitrary function that takes the current data frame and returns whatever. And so if you have something that you can't do in a chain, you just throw it into the function inside of your pipe, do it inside of the pipe and have it return the object there, and you can still keep your chain going. Okay, so this is, again, my code here. Compare this is what I normally see from around the world and people's blog post or whatever popular data science Medium post doing stuff like this. And if you do something like this, it's really hard to read. It looks like, my eyes sort of glaze over as I'm reading this. It's not clear what's important, what's not. There's a bunch of intermediate variables. There's a bunch of mutating. It turns out that mutating is actually something that makes people's brains hurt. So people's brains can only typically keep 7 ± 2 objects in working memory at a time. And so if you have to keep track of like what's being mutated or changed, that's just cognitive overhead that makes your job harder. In addition, we can run this, and if you run this, it looks like it works, but we also get this mess of like the pink splotch of death here. And if you're familiar with pandas, you've probably seen like this infamous setting with copy warning error that's like the bane of pandas developers everywhere. And then you search for like what that means, and you read all these Stack Overflow things, and they don't make sense. And they basically say, go put some copies in here or there, and if you do that, these might go away, but no one really understands what this is. Note that there aren't any warnings here when I run this. It's completely clean, and we don't deal with that. So if you use this style that I'm showing you, you won't have any of these issues. Xiaoping says, should we ignore that warning? I mean, if you want to. My point is that you'll never see the warning if you follow my advice. You won't ever see it. If you do, then you'll have to sort of roll the dice and figure out what it means and why you're getting it, and sprinkle your code in with a lot of copies or whatnot, and just sort of hope that it works. Yeah, Daniel says, it tells me to use loc. I use it, it still shows up. Yeah, so yeah. If you use this style here, and basically this is, most of this derives from people using a sign. So if you use a sign, which a lot of people aren't familiar with, then you get around those issues. John says, how do you do an apply inside chaining similar to an assign? I guess I would want more specific, like what are you trying to apply, John? Maybe I can answer that if. Okay, well, while John is thinking there. So and some other common complaints about this are like, Matt, this is hard to debug, right? I can't debug it. I don't have these intermediate variables to debug. And my comment to that is, it's actually easier to debug. I've got a couple ways here, and I'll just sort of demo them. So here's my tweak autos right here. I mean, what I like to do, you saw that I built this up from scratch, right? So I like to do this interactively. So I'll just like comment these out and like walk through it as I'm going. Okay, so what happens when I uncomment the pipe? Then this happens. What happens when I do this? Then I get an error because I didn't comment out this part. So you can just sort of like uncomment these and walk through each step one at a time and see what's going on with the intermediate state of your data frame, but you're not left with all this like cruft sitting around. Now, some other things that you can do to debug these as well is you can leverage that pipe method I was talking about. So if you do want an intermediate variable, and you might want that, guess what? We can pipe in this little function here called getVar that does a little hack. It says, remember, pipe takes a function that takes your the current state of the data frame. So this is the state after pulling off these columns here. And we're also going to pass in this name right here. So this is just going to hack into the global variables and say, make a variable called df3. And so if I go down here, I now have a variable called df3, which is that intermediate variable if I really wanted that, right? But I don't have to necessarily make 50 intermediate variables, and who knows if I want them or not, or it's unclear. I can just use this little hack here to get them as needed. Alternatively, another cool thing that I like to do is leverage pipe to call display. If you're familiar with Jupyter, you'll note that generally Jupyter only displays the final execution on your cell here. Well, maybe I want to also look at this data frame right before I convert everything at the types and drop the column here. So I'm just going to pipe in this little lambda function here. Again, it takes a data frame and just going to call out to the Jupyter or the IPython display function, and it's going to use short circuiting to also return the current state of the data frame. And so when you run this, if you look at the output here, there's actually, this output up here is what it's printed out. Okay, so this is the intermediate state if I really wanted to see this. And then here's the actual output of the cell down here. So we can leverage these to make intermediate variables or do whatever I need to inspect the data frame. Okay. So there are some questions. William said, can we add logic to the chain? Yeah, I'm going to show adding logic here. John is talking about apply, so I'll show some apply as well. So my next point here is don't mutate. So I got a quote here from a Pandas core developer. Jeff Reback says, you're missing the point. Inplace rarely actually does something in place. You're thinking that you're saving memory, but you're not. What Mr. Reback is referring to is that a lot of the methods in Pandas have this parameter called inplace. And when you do inplace, it does not return a data frame. It updates the current data frame. And this kind of puts a big monkey wrench in chaining because you can't chain if nothing's returned. But a lot of people are like, yeah, that's why I don't want to chain, Matt, because I want to do inplace because I'll save memory. Well, it turns out if you actually open up the source code for Pandas, you like Mr. Reback says here, you're not saving anything generally with most in-place operations. Most in-place operations don't do things in place. Rather, they make a copy and then they take the copy and shim it into whatever you were working on under the covers there. So you're not really saving any memory. All you're doing is basically making it so you can't chain. In fact, there is a bug report. I've got it linked here. So bug issue 16529 is a bug to remove inplace from Pandas because it's just silly. And most Pandas developers, the core developers, think that you shouldn't use it. And it was a mistake in the first place. So in general, there aren't any benefits to using inplace. You can't chain. And you know, if you start thinking I'm going to be doing these mutating operations, then you get all of these settings with copy warnings that, again, like I said, most people have no clue how to deal with and are very confusing. Okay, so that is my mutation rant here. Don't mutate. So Pandas is an in-memory tool. It's going to use memory. You're going to be dealing with copies anyway. That's just how Pandas is. Maybe in the future, Pandas will have the ability to do some smarter things with like copy on write, that sort of thing. Having said that, if you use chaining, the chaining style would actually enable in the future some hypothetical Pandas compiler to optimize your code, much like as database query engine optimizer would work. If you're not using something like chaining, then you're sort of throwing that all out the door because it would have to do eager computation of all of that. So it is what it is. Generally, I recommend to my clients or students that they have 3 to 10 times the amount of memory as the data that they're processing. Okay, so maybe to John's point here, here's my next section, which is called apply. It's actually called don't apply. Don't apply if you can. So I'm just going to make a data frame here called autos2, which is, you know, someone was saying like, would you make an intermediate data frame? And so, yeah, I actually do make an intermediate data frame, right? And what I do is I load the raw data and then I make this tweak. And then with the result of the tweak's sort of my intermediate data frame that I'm going to work with. And so generally I'll work with this tweaked version rather than the raw data and further process the tweaked. And then I might, you know, update this tweak function as needed if I need to from further processing. But let's do some application here or calling apply. So, you know, this data set is very US centric and the US cares about miles per gallon, but they're about the only place in the world that does. Most people use something that might be more sensible, like liters per 100 kilometers or whatever that means. I'm obviously based in the US, so that doesn't make sense to me. But, you know, if we wanted to convert some of these metrics like city miles per gallon to liters to 100 kilometers, you can do that. And here we go. And so this is the conversion of miles per gallon to liters to 100 kilometers. Now that works, and you might say like that looks good. We got Python code to make that work. However, it's kind of slow because what it has to do is when you call apply here, what it's going to do is it's going to take each individual entry there and pull it out from the series and stick it into this function and then push it back into the series. So there's some overhead to doing that. Contrast that to this call right here. I'm just saying, take 235 and divide it by Otto's City 08. They return the same result, but this is what's called a vectorized operation here, where again, modern computer architecture allows us to have this block of memory in data, and then we can do a division on that block of data without pulling it back through Python and having the overhead of that. In fact, if we look at the cost of that, it's about 50 times slower to use apply than it is to use the non-apply version here. So especially if you're doing heavy math operations with numbers, generally not recommended to use apply to do that. So yeah, so here, 8.9 milliseconds for this, and 200 milliseconds or 200 microseconds for the vectorized operation there. So this is about 40 times faster there. Williams says, so yeah, Williams saying that the vectorized operations do not support logic conditions. Kind of correct. I'll show an example, William. Okay, so let's take another example here. Maybe we've got the make and we want to like generalize make or have some sort of hierarchy, right? And we want to say like, is this an American makes? So I'm going to make a function called isAmerican, and basically it's going to take a value here and it's going to check if the value is in this set here. Let's do apply that, and let's do this isIn method here. And we'll just time those, and let's look at the timing differences of those. Okay, in this case, you see like 1 millisecond for apply and 800 microseconds for isIn. So, I mean, this is kind of, I mean, maybe 15%, 20% difference, but for me, this is, I mean, it is significant, but it's not like a huge amount, right? Versus like 40 times faster per se. And the issue here is that, like I said previously, Pandas, if you look at autos2.make, this is a categorical type, and categorical types, there are some optimized, but they still have to like work through Python strings at some point. And so you do have some overhead for doing that as a string. Now, let's just throw it back as a string type. I'm gonna make this autos3 and give it a string type, and let's just time it as a string type instead of a categorical type. Okay, and then if you look at when it's back as a string, the isIn is like 3 times faster. So there is, what's my point here? Oftentimes by using categorical types, you save quite a bit, right? 6 milliseconds versus basically 800 microseconds. So about 6 times faster by using the categorical type and using isIn instead of apply. Now, again, William's question, I want to do Boolean operations. And yeah, I've got a section in my book on that. William, for one of my clients, I spend a good deal of time like working on Excel. Basically, we want to convert this fancy Excel spreadsheet to Python code. And it was one of those spreadsheets where it's like they had a beefy laptop and they had to shut everything down. And then once a month, someone would load this data and then they would run some macro and cross their fingers that they didn't run out of memory or whatnot and let it run for a couple hours. And then it would check, it would, basically run the company by this Excel macro, right? And they're like, we want this to not be in Excel. And so, I've had a bunch of if statements, right? And so, long story short, can you convert if statements to pandas? Yes, you can. So let's make this country here. Let's do this with an application here. And, that tends to work. Let's do this. This is how I would do this without an application. And you can see that this is indeed a bit slower here. And so what are we doing? We're saying that and this is, I'm just for fun, I'm going to try and make this a little bit faster. So what's another term for country, like origin? So it turns out the assign actually makes a copy here. So we probably have some of the overhead here for making a copy. There we go. And so what this is doing is we're saying, use country. And if we're in that, return US, otherwise return other. Pandas does have a way to do this. And I admit like the syntax is clunky, but it is this where operation. Okay, so where is a little bit weird, William, but basically you're going to run that on a series. And you're going to pass in a Boolean operation or a Boolean array here. Wherever this Boolean array is true, you keep the value of this. So if some case, then this, otherwise this right here. So that's how that works. It's a little bit weird. And if you're used to like its else statements, it's a little bit hard to read. But it does work. Now, in this case, it's, there's not much difference here because we're dealing with categorical operations here. So there are some other ways to do this as well. This is actually what I think is a big gap in Pandas API is that it doesn't have this NP select. So Numpy has this thing called NP select, which basically lets you pass in a bunch of Boolean flags or Boolean arrays, and you can pass in a corresponding value or series. And basically, if the first thing is true, it takes that. If the next thing is true, it takes that. If the third thing is true, it takes that. And the first one that evaluates to true, it takes it. So it basically lets you do like a nested if else. I wish Pandas has that. It doesn't have that really. So you need to chain these wheres if you want to. And if you look at this, there's also an MP where, which is where Pandas got the where. I just wish that they would have followed suit and done the NP select. Now in this case, there's not really a lot of difference here. The apply is actually a little bit faster. And I'm actually okay with apply for string operations. However, having said that, I don't have it in the slide deck here, but in my book, I do have an example that is very similar to something I did with a client, this spreadsheet client, where they had a bunch of logic. It's like, if this, do this, else if do this. And you can do that with apply. It turns out that if you write that as like a where or a select, it's 400 times faster with numeric data. So can you use apply? Yes, you can. However, if you are using apply with numeric data, you probably want to be careful, and you probably want to rewrite it as like either a select or a where. Okay, question from Nick. Nick says, does this mean I can use autos to city 08 just like any variable so long as the type of the column makes sense? E.g. return autos to assign autos to MPG raised to the 8th power. So I think your question, Nick, is can I use a column from a pandas data frame and do math operations on it? Yeah, you can. They support addition, multiplication, power operations, whatnot. Your assign syntax is a little bit broken because you need to give it a column name in your example that you put in there, but you can do that. Okay, so hopefully that sort of answered Williams and John's question there. If not, let me know. Okay, last section here, master aggregation. So, oftentimes your boss will come up to you and say, I want you to compare this by, mileage by year or cost per year or something like that. And anytime someone says cost, per something or by something, your mind should immediately think we need to do a group by or a pivot on that. And so, if I say by year, let's compare mileage by country by year, you think I need to do it group by year. So let's do this. I'm going to write this in a chain here. I'm going to say autos group by year and take the mean. Now let's, because this is written this way, I can, just step through it. Here's my data, autos 2. I'm going to do a group by year. Now group by in pandas is actually lazy. So remember I said that I could see a future where pandas or some competitive tool similar to pandas supports some query engine optimization and can do optimizations here. In this case, group by doesn't take any action until you actually apply an aggregation to it. So this is a lazy object. We're going to say mean on this. And when we do this, we get a data frame out. In the index of this data frame, now we have the year, whatever we group by, and then all the numeric columns, we have the summaries of them. So this is pretty powerful. I mean, I could write this as one line of code. I don't write it as one line of code because I want it to be easy to read, but very easily I can summarize, this is the average of every entry by year. Okay, and then if I just want to look at like combined mileage and speeds per year, I can do that, and I can just pull off those. There's combined mileage and speeds per year. Now, one thing to be aware of is the order of these. You can say group by, pull off these columns, and then take the mean, or you can say group by, take the mean, and then pull off these columns here. So if you just think about this, again, this is something that a query optimizer potentially could do in the future, but Pandas doesn't have that right now. But if you look at this, this first one here is only taking the mean of those two columns versus this one, it's taking the mean of all the numeric columns and then pulling off those afterwards. And you can see that it's like twice as slow to do that, which makes sense. It should be slower because it's doing more calculations there. So if you are doing some group bys and you only need certain columns, you might want to be cognizant of that. Now, the next part here, I'm just going to load some styling. This is some Seaborn to set some styles here. So I'm going to do some plotting here. So let's just walk through what I'm going to do here. I'm going to group by year, pull off these columns. This is still lazy. Take the mean. Okay, here's the mean. And then I'm going to stick a plot on this. If you're not familiar with plot in Pandas, it's super powerful. Basically, if I just do a plot by itself, it's going to do a line plot, and it's going to plot the index along the x-axis, and each column has its own line here. So here's a line plot, and it's complaining a little bit about a font that I have in my style up here that's not found in this installation. But basically, here's the speeds, and here's the combined mileage, the average by year. And we can easily see by visualizing this that these have gone up as of recently. Now, it's really easy now for me to come in here and say, oh, I didn't want the mean, I wanted the median, right? And here is the median by year, right? Or I wanted the 99th percent quantile. So I can say quantile 0.99 here and get the 99th percent quantile. So just by changing that aggregation function or changing which column, I can pull data in and out. Maybe I want to get highway 08, right? And you can see that these tend to make it easy to do that. Okay, so I'm getting a warning here that, I need an aggregation here. There we go. So there is our highway 08. You can see that highway sort of trails combined, which sort of makes sense. Okay, so this cell is basically what I was just doing here, just sort of switching these aggregations off with different things and tacking on a plot to them. So if you write it in this chain style, it makes it easy to play around with and swap things in and out very easily. And it reads, again, like a recipe. Now, we said by country by year. So that might give you pause, like, how do I do that? And so what I'm going to do is I'm going to make a new column called country. I don't have country right now. I do have that function. function to get country there. And then after I have a new column called country, I'm going to group by year and country and take the mean. So if you look at that in my index now, I now have two things in my index. This is called a hierarchical or multi-index. And so, here is 1984 for the US. These are the average values for other countries. These are the average values. So again, I could write this as one line of code, right? Pretty powerful to do these aggregations. And I can step through this if I want to. I can pull off different columns, and this makes it very easy to do answer some of these maybe tougher questions here. In fact, I can even apply my own aggregate here as well. So here I'm going to say I'm going to group by year and country, and instead of just doing the mean as the aggregation, I'm going to take the minimum, the mean, and this customized one called second to last, which is an aggregate function that just takes the second to last. And now if you look at this, I've got a hierarchical index here, but I also have hierarchical columns. So for each numeric column here, I've got the min, the mean, and the second to last entry in there. So this makes it really powerful, especially if you're looking at like financial data. Like you want to look at like the open, the close, the high, the minimum, the total number of cells per day. Really easy to do that sort of operation in pandas. That could be kind of annoying or painful in other tools. Okay, so I'm just going to go back to a simpler version here. So here we go. We're going to group by year and country. We're going to take the mean, and then we're going to plot this. So remember, plot by default does a line plot. It's going to plot the index along the x-axis. Now, if you look at the index here, it's multi-index. So it's got the year and the country. If you do that, you get this sort of weird plot here that has this tuple in the index. Probably not what you want. You probably wanted just year there. And so let's see what we can do here. This is the mean. This is what we had before we plot it. We're going to do what's called an unstack operation here. So this is one of those operations that can be a little bit confusing. The more you work with it, the easier it will be. What this is going to do is going to take that country index, and it's going to flip it up or unstack it and stick it up as a hierarchical column up here. And there we go. Now we have in the index, we have the years, and then we have hierarchical columns. So for city, here is the other values, and here is the US values. So once you start understanding that, you can also see that you can do like the reverse of that. And you can say stack here, and that's going to stick country back down there in the index. So you can keep stacking or unstacking as needed, or you can unstack different levels as you want. But what I'm going to do here is, let's just sort of walk through this now. I'm going to, so here is our mean value here. Let's unstack it. And what I'm going to do next is I'm going to pull off the city. Now, this is a hierarchical column here. So if I pull off city, I'm going to get this sub data frame with these two columns down here. So let's do that. Okay. And then what I'm going to do is I'm going to plot this. This is going to plot each column as a line against the index here. So there should be two lines, one for US, one for other, which would be the average city mileage. There we go. And then what I'm going to do, is I'm going to just use this matplotlib call here to stick the legend out to the side here. So there we go. There is the average mileage per year for the US versus other. And you can see the US sort of bumped up and then came down here, and the US crossed other sometime in the mid 2015s, according to this data here. Gregory says that is cool and confusing. Yes, that's true, Gregory. Super cool and potentially super confusing as well. Same idea as pivot in Excel, pivot table. Yep, exactly same idea as pivot table. So if you're familiar with grouping in databases or in SQL, sort of similar to this, probably a little bit easier and more flexible in pandas, I would say. So here what I'm going to do is just give you another example here that powerful and confusing here. So group by year and country, take the mean here, and unstack that. And this is one of the reasons why I like writing it like this, because I can walk through these chains here. If I unstack this, this is going to stick country up in the columns here. If I take the city, this is going to pull off the columns below city. If I do rolling here, this is going to do a rolling average. So if I want the rolling 3-year average, I'm going to say rolling 3. This is lazy, and I'm going to have to apply an aggregation to that. So I'm going to do the mean here. So for every 3 years, this is the rolling average, and then I'm going to do a plot of that. So this is basically smoothing out what we saw up above here. So there's the per year, here's the 3-year average. And then this last call just sticks that legend on the outside there. Okay, so that is my grouping example here. So in summary, so Xiaoping says it unstacks the last column in the group by. So let me just talk about unstack one more time here, just so we're clear what's going on there. Okay, so there's our non-unstacked version here. What unstack is going to do, Xiaoping, is going to take country and stick it outside, or sorry, it's going to flip it inside under each of these columns here. So just watch when I do that, it pops it up there like that. And then if I pull off city, it's going to pull off the subcolumns from that. Daniel says unstack gets rid of the multi-index basically. In this case, it does. It doesn't in general, Daniel, but in this case, it does. Unstack pushes things from a column index down to, unstack pushes things from the index up to a hierarchical column. Stack takes things from the column and pushes them down into the index. Whether that flattens or gets rid of the multi-index depends on what type of column or index you have. Yeah, and Xiaoping says if you had 3 indexes, it would stack just the last. Yeah, so let's just show that. We could say we want to do like year, and then make, and then country. Okay, and so if we had that, there's year, make, and country, right? If we do an unstack here, it's going to stick country up there. If we did another unstack, it's going to stick make up there as well. So you can sort of go crazy with these as well. And there you go. There you have, for each metric, you have the country class hierarchy, and then you have the makes below that. Okay. Okay, great questions. So in summary, let me first ask, are there other questions about group by?
Hey, Matt, there was a question on YouTube. If you ever, do you ever pull out those functions, those cleaning functions into like separate files, or do you keep them in your core notebook?
Yeah, that's a great question. Do I keep the functions? Do I pull them out? So the whole reason, I mean, one of the reasons for writing this as a function and having it be self-contained is that if I do need to like do some processing on this, maybe I need to make a model from this and deploy this to a server. This is the logic to do it. It's all right here, self-contained, right? The other reason I like it in a function like this is because if it is a function like this and it runs, then I know that I'm not dependent on anything else, especially if I can restart my server and run it from the start. It kind of eliminates bugs that way as well. Oftentimes what you'll find in notebooks is that people violate a lot of best practices from coding, which is what it is. So I have a background, I have a CS degree. So I mean, background as a traditional software engineer. A lot of people who are using notebooks don't have that background and don't necessarily want to be programmers. Needless to say, they are programming. And if they take a little bit of time to use some best practices of programming, they actually reap the benefits of doing that. So yeah, I do like the notion. Generally programmers try to avoid global variables, and notebooks we're generally using them all over the place, which is fine. I get that there's a difference there, but at some point you might want to try it and make your code more robust. And one of the ways you can do that is you can make a function like this.
There's also a question as to whether you can consider this functional programming.
Whether this is functional programming. So I'm going a little rant about that. I wouldn't consider this functional programming. However, Python is a multi-paradigmatic programming language. What that means is Python supports object-oriented programming, where you can make define classes and make instances of those. Python also supports imperative style of programming. So that would be like what you do with like a C or a BASIC, where you have procedures and you have data structures and you call those procedures. Python supports that as well. And then Python also has functional constructs, which is what you'd see in like a Lisp or a scheme, where you have like lambdas and map and reduce and apply. And so if you're using functional programming, do you chain things like this? Yeah, you might, but I wouldn't classify this as functional programming. This is more of a flow style, where every object that you call is returning another object, and we're just chaining these operations on top of each other. Is it functional by definition of functional? Yeah, I guess you could make that argument, but I probably wouldn't say that, just because once you label something as functional, that kind of turns off or scares off a lot of people from that. Okay, other questions? Okay, Xiaoping says, or William says, how does Python know which labels to stack, unstack? By default, William is going to unstack the innermost. But if you want to, you can tell it what level you want. So let me show you one more thing if you're not familiar with it. Autos 2, you can say like unstack, and you can put a question mark here. And if you put a question mark here, it's going to pull up the documentation. So by default, it uses level -1, which is the innermost level, but you can change that level to unstack the outermost or whatnot. Okay, Ed says, thanks, and more importantly, immediately usable stuff. One thing I might add is to demonstrate using T. Yeah. Yeah, one of the things you can do, that Ed says, is you can do a transpose here. So if you're familiar with matrix multiplication or just matrix manipulation, transposing is flipping the rows and the columns here. So if you want to transpose your data, you can just stick a capital T after that to transpose it. Sometimes that's useful. I mean, you can actually implement transposition with unstacking in pandas, but generally where I use transpose is to view a little bit more data. It turns out that because pandas is going to print the column names up here, and column names might be a little bit wide, when you transpose your data, you generally, a lot of times I do at least, have numeric index entries, and those aren't quite as wide as the column. So oftentimes by transposing the data, just lets me see a little bit more on my screen than what I'd see otherwise. Let's see, Gregory says, does pandas play well with MyPy at all, or is typing data frames not worth the trouble? That is a great question. And I haven't seen, so recent versions of pandas, they have been adding some type information. For those who aren't familiar, Python 3 supports what are called type annotations. Python, the language, basically ignores them, attaches them as metadata, but it doesn't do anything with the type annotations. But then you can run third-party tools such as MyPy, which will tell you whether you're violating them. My sort of issue, and I imagine that it just gets complicated because some of these operations, it's not clear what they return. They might return, 5 different things. And so once you have something that might return one of these things, and then you call something else on it that might return 5 different things, you sort of have this combinatoric explosion of things that can be returned. But I haven't used typing in sort of anger or happiness on pandas. I generally use pandas inside of Jupyter, and I don't know that Jupyter is able to take advantage of typing information right now. So for me, at least, I haven't really seen a benefit for it. Now, one thing I have thought about, Gregory, is the using typing information for doing some sort of schema validation, something like that. And I haven't seen that being used. I mean, there are tools to do like schema validation of data frames and other objects that you would use pandas or SQL or pandas or whatever for. And I don't know that the Python typing system, well, it could be flexible enough, but generally, if you're doing some sort of schema, you want to say like, this is limited to these data sets and it has to have, maybe a mean value of this or something like that. And I guess you could do that with Python typing, though I haven't really seen anyone trying that. That might be, maybe that will come to pass sooner, but I haven't seen a lot of stuff going that way. It's high risk, high reward typing. Maybe, yeah. I haven't seen many rewards from the Pandas side so far with that. I mean, for me, I think the best reward would be the completion. And that is one place where chaining sort of falls down, is completion sort of breaks apart after you do a method call, right? And so chaining might help with that. But I just think that just due to how Pandas is, and that like you have these objects that can return 5 different types, I don't know how completion, I mean, it seems like just a mess if you're given the options to complete a data frame, a series, a number, a string, a date, and it's just going to do the union of all those. I don't know what that would look like. Nick says, I have to create a lot of data frames for work, and I end up using a for loop to create a 2D nested list, converting it to a data frame. Is there a better way for creating a data set and converting it to a data frame? I mean, it just depends on what your data looks like, right? I mean, you might have to jump through some hoops to do that. I couldn't really say without looking at your data more, Nick. Okay, great questions. Okay, so in summary, if you use the correct types, not only will you save space and memory and your operations might be faster, they'll probably be more correct, and you'll probably have to go through this process of understanding your data. So you're going to get benefit, and as someone who does machine learning, making predictive models or whatnot, one of the best investments you can make is to understand your data. So I think that's actually very useful. As you can tell by listening to this, I'm a huge fan of chaining. I highly encourage you to try it out. Most of the reports I get back are that people who start adopting it are sold on it. I see a lot of people who are somewhat skeptical of it. However, I've never seen someone who's tried it out and said, my non-chain version is better. So, take that for what it is. People seem skeptical of it because it's somewhat novel. But again, this is basically what all the core developers of Pandas are suggesting. It's just that there's so much cruft out there in the world that either doesn't know about it, or it's sort of like newbies spouting nonsense to newbies, and the blind teaching the blind. So this Pandas 1.x cookbook, which I did not write the original Pandas cookbook, but I did this version here. I guess it came out a year or two ago. But basically, I like the content of it. I did add some more chapters and cleaned up some stuff, but I did make a heavy emphasis on the chaining there. And I think it cleaned up the code quite a bit by doing that. So your code will be more readable. Like you see, it's going to read like a recipe if you can do this. You will have less bugs because you'll have less code. Your colleagues will be able to read your code. It's going to be easier to debug as well. I showed you how to debug it. After years of not using this chaining style, then going to it, it's much easier to debug. For those who are like fans of mutating and think that it's the greatest thing, it's not. There's no point in doing it. So you might as well embrace chaining. Apply is slow for math. So if you have math operations and you need to do some sort of if statement, look into using like NP select or NP where or pandas where. Generally, it's going to be a lot faster, especially as you get more data, larger data. Apply gets really slow. So those where operations get a lot faster when you get more data. And then these aggregations, they are powerful, and I get that they're confusing, right? I mean, I've been using pandas basically since it came out. And I don't claim to have the whole pandas API memorized. It's too big, it's too complicated. But if you master sort of the 20%, you get the 80% done. I think one of the places you should spend your time is learning how to do group bys and learning the basics of hierarchical grouping and unstacking and combining that with plotting. You're going to get a lot of leverage out of that. It's going to allow you to slice and dice your data very easily and make sense of it. So thanks everyone. If you like this, you can follow me on Twitter, Dunder Harrison. I tend to tweet a lot, especially these days, about pandas because I'm working on the new book. When is the new book out? Hopefully soon. Yeah, follow me on Twitter or LinkedIn, and there'll be more news of that. I'm in the middle of getting feedback and updating drafts on that right now. Yeah, and then if you like this, if you're interested in the Idiomatic Pandas workshop, you want to basically take your pandas code and work through cleaning up your pandas code with others and groups, I'm going to be offering that workshop. So again, follow me on Twitter, reach out to me on LinkedIn, and I'll have more information about that as well. So thanks everyone. Pleasure.
Hey Matt, I had a quick question.
Yeah.
You had mentioned alternatives to pandas, and I was just wondering, is there other tools that you're seeing people are using or that are getting more popular?
Yeah, that's a great question. So here's sort of my answer to that. Like, is pandas the greatest thing since sliced bread? No, it's not, but it's for better for worse, it's the tool of choice for a lot of people. And what I'm seeing is that not only is it the tool of choice, but I don't know that pandas will be around forever, but I think for the next while, the pandas API will be around forever. So what you're seeing is there's probably a dozen, if not 24 tools that are basically re-implementations of the pandas API. So there's like Dask, which basically scales out pandas so it runs on multiple computers. And then there's Ray, which does something similar. And then there's like CUDF, which is like pandas, but for GPUs. And then there's like Rust implementations and other implementations that are basic. I mean, and the promise of a lot of these is like you change the import from import pandas as NP to import whatever library, import pandas as PD to import your library as PD. And most of your code should stay exactly the same, right? But it's just going to use our underneath cover. So for better for worse, I think we're sort of stuck with the Pandas API. Personally, I don't think the Pandas API is the best API. As someone who's using it, but also teaching it to people, it can be pretty confusing. But I think it's where we're at for right now.
Thank you. Well, with that, I think we're gonna wrap it up. I mean, thank you so much, Matt. That was awesome. Seems like there's a lot of questions. One of the most engaging one we've had, actually. There's a lot of interest and there's a lot of good feedback. For those that want to go back and look at it, I will have the YouTube video cleaned up and posted at some point. They did ask about your notebook, Matt. I wasn't quite sure if that's something you do share usually or not.
Yeah, let me get that. It is right now, it's as a gist on GitHub. So let me get that link here. I'll just put that in the chat. Yes, whoops. Send it to everyone. Yeah, and
Got it.
So there's that. Yeah. So leverage the notebook. Try it out. Let me know what you think. My take is that people who leverage this are much happier with their code, and their colleagues don't want to poke their eyes out when they read their code. So take advantage of it.
Yeah. Well, thank you, everyone. Once again, thanks, Matt. If you ever need anything, just let me know, and hope to see everyone at a future meetup.
Okay.
And thanks for joining us on this Wednesday evening. Thanks, Matt.
Thanks,
See you guys.
everyone.
All right.
Yep.
Bye, everybody.
Bye.